Hello everyone, Mr. Lee here. In this video, we are going to go over acceleration. Alright, so a good place to start is the definition for acceleration, so let's go from there. Okay, acceleration is the rate at which an object's velocity changes with respect to time. Okay, so acceleration is the rate at which an object's velocity changes with respect to time. Now, like a lot of things in physics, the definition of a term, or the variable in this case, is also the equation. So let's come up with the equation as well. So first off, acceleration is a vector. Direction really matters for acceleration, and we'll see why in a little bit. So we have acceleration is the rate at which an object's velocity changes. So we have a change in velocity with respect to time. Okay, so it's how much a object's velocity changes over a period of time. And the units for acceleration, I'm going to show you two kinds. The first one will be meters per second. Okay, and I personally like starting off with this as our units, but the most common form of the units will be meters per second squared. Okay, this is the most common form, but for us, because we're beginning to learn about the kinematics, let's use this one. And let me tell you why. With this unit, meters per second, what it tells us is that it is the velocity, meters per second, that is changing with respect to time, seconds. Whereas meters per second squared, it doesn't really, help us with much. Okay, so with that out of the way, I also want to point out what velocity or what acceleration is not. Acceleration is not the following, okay? How fast an object is moving or how slow an object is moving, okay? The motion of a object, aka when you're describing how fast or how slow, that's velocity. That is not acceleration. So I'll put that right there. How fast, how slow. This right here is the definition of velocity. Okay, definition of velocity. It's very important to know this, especially because a lot of people use the term velocity and acceleration like the same thing. Okay, so now what I want to do is I want to come up with a list of criteria that you might see when we are solving different problems, and these are the keywords that let you know that an object is accelerating. So we can say an object is accelerating if it is speeding up. Okay, speeding up. That does not mean that the object is moving fast. It is speeding up. So it's just getting faster. Right, so let's put that in there. Getting faster. Another one is if it is slowing down. Okay. I guess this means it's getting slower. Another one is, now this one will come up later, but this one is changing direction. Okay. Now these are the three criteria that lets us know if an object is accelerating. If it's speeding up, if it's slowing down, or if it's changing direction. And so what I want to do is I want to showcase why these are the three criteria. Well, we'll do the changing direction one later. We'll do the first one. Okay, an object is speeding up if the velocity is changing. For example, if you had an object that was moving at 5 meters per second at 0 seconds, and then after, let's say, 5 seconds, it was still moving at 5 meters per second. And let's say after, 30 seconds, it's still moving at 5 meters per second. Okay, this is what we call constant velocity. So this shows us that the velocity is not changing. So if we take a look at the equation, a equals delta v over delta t, your final velocity, 5, minus your initial velocity, 5, over the change in time, 30 minus 0, this gives us an acceleration of 0 meters per second per second. Okay, so there is no acceleration because the velocity isn't changing. So if an object's velocity was speeding up, we can use the same example here. We can say that it started off with 5 meters per second, and then, let's say it has 6 meters per second, and then 7 meters per second, all at times 0 seconds, 2 seconds, and 4 seconds. We can see that the object is speeding up. And vice versa, right? If we go from 7 meters per second all the way to, let's say, negative or just 0. We'll just say 0. 0 meters per second. Then it went from moving to not moving. Okay, so it is slowing down. Now, a good way to memorize this is if you look at a car. A car has all 3 of these aspects within the driver's seat. Getting faster? Why, that sounds like the gas pedal. Getting slower? Kind of sounds like the brakes. Changing direction? Steering wheel. Okay, so if you are in the driver's seat, what you have in your control are all of the tools for the car's acceleration. Good. All right. Now let's see what acceleration means in terms of numbers. So what I'm going to do is I'm going to create a little table here, and this table is something that you should definitely memorize. Okay, because I don't know, I think it's very important, so you should memorize it. All right. So we have velocity, acceleration, okay. SP, upward arrow, that means speeding up. SL, down arrow, means slowing down. And we'll do an equal sign for no change. Okay, there's no change. All right. I'll just write that in. No change. All right. So if you have an object with positive or negative velocity, and your acceleration is 0, okay, that means that the positive or negative velocity is now not changing, so the object is no change in motion. All right, first one. Next one, if you have an object that is moving in the positive direction, so let's say upwards or to the right, and it is also accelerating in the positive direction, okay, so the change in velocity will be towards the positive direction, and it's already moving in the positive direction. That means the object is speeding up. Okay. On the other side, if the object is moving towards the negative direction, and it is also experiencing a negative acceleration, that just means that the velocity will constantly change in the negative direction. That means the object is speeding up. Now I'm going to do a little star here. Let's do okay. So a little star. Okay, this is a warning flag. Many students believe that positive acceleration means the object is speeding up. Okay. Many students also believe that a negative acceleration means object is slowing down. All right, so that's a red flag. Many students believe that a positive acceleration means that the object is speeding up, and many students believe that a negative acceleration means that the object is slowing down. This is not true. This is a false statement. Okay. All right. Now, we can see here, you might be thinking, wait a minute, Mr. Lee, here we had a positive acceleration and the object was speeding up. So you're saying that's not true? No, that is not what I'm saying. I am saying that the object is speeding up if and only if the object has a positive velocity and a positive acceleration. You must meet both criteria. And so one thing that you might notice here is that if your velocity and your acceleration have the same signs, that means the object is speeding up. And vice versa, if we have an object that's moving towards the right, but it is accelerating towards the left in the negative direction, that is when the object is slowing down. If you have an object that's moving towards the negative direction, left or downwards, but the object has a positive acceleration, that means that it's slowing down. Okay, notice here, if the signs are opposite, that means that it is slowing down, which goes back to my red flag over here, where I stated many students believe that a positive acceleration means the object is speeding up. Here we have a positive acceleration, but the object was slowing down, and it's because there was a negative velocity. Okay, all right, last one. We're going to have a zero velocity. So the object is not moving at all, but it has a positive or a negative acceleration. So that must mean that the change will be going towards the positive or negative direction. So in this case, the object will be speeding up. Okay. If you have no velocity but a positive acceleration, over a period of time, you're going to end up with a positive velocity, and vice versa. If you are not moving, but you have a negative acceleration, you're going to speed up, but in the negative direction as well. Okay, so make sure you have this table down. Things to memorize. Well, basically this entire table. It's very good to know so that you don't get tricked. Now, we're talking about this whole idea of acceleration and what it means for change of velocity. Now, I like to personally take a look at it with the scope of numbers. So let's do a quick velocity acceleration chart. So let's say, well, let me erase that chart. Let's do a velocity chart, and let's do a velocity and time chart. Velocity, time, and then we'll do, yeah, velocity and time. There we go. Okay, so let's say that your starting velocity, okay, at time 0 was, we'll start off simple. We'll say it was 0 meters per second. Okay, and we're going to make our acceleration for this entire example. Let's make it 2 meters per second. So meters per second. Once again, I like meters per second when we start off, but we can change it later to meters per second squared once we get used to it. Okay, so at 0 seconds, the object is not moving, but it will be accelerating with 2 meters per second. So after 1 second has passed, okay, after 1 second has passed, the object will have a change of velocity of 2. So after 1 second has passed, the change of velocity will be 2. We started off with 0, and now we end up with 2. Okay. After 2 seconds have passed, our acceleration is not going to change because that's not what we're focused on here. That means that this previous velocity will change by velocity of 2. Okay, so let's try another one. After 3 seconds have passed, the acceleration is not changing, so that must mean that the initial velocity of, or the previous velocity of 4 will change by a velocity of 2 to have 6 meters per second. And so what we see here is we have a positive velocity with a positive acceleration, and according to our chart, when we have positive velocity and positive acceleration, the object is speeding up, and we can see that the object was at rest, but then eventually it was moving in a positive direction, okay? And therefore we can say it speeds up. All right, now let's try something, let's try the flip side. Okay, let's try a velocity time, okay? We'll start off with, let's do one where it's a little bit different. Let's do -1 meters per second at 0, and then we'll have an acceleration of -1 meters per second squared, okay? All right. So at 0 seconds, the velocity is at -1, and it will change by -1 after every second. So after 1 second has passed, the velocity will change by -1, so our new velocity will be -2. Okay. After 2 seconds has passed, the velocity will change by -1, so it'll now be -3. After 3 seconds have passed, the velocity will change by -1, therefore we have -4. Okay, so we can see that the object, we have a negative velocity with a negative acceleration. According to our chart, if these two signs are the same, we speed up. Okay, and we can see here that the object got faster and faster and faster towards the negative direction, so it got faster. All right. Okay, so I'm going to throw a curveball at you. Let's see what we can do from here. So velocity, time, acceleration. Now let's say we started off with a negative velocity of -4 meters per second at 0 seconds, and we're going to change our velocity by let's say 2. Okay. All right, so this is +2. So we have a negative velocity with a positive acceleration. If the signs are not the same, this means that we will slow down. Okay. So after 1 second has passed, the velocity will change by +2. So -4 plus +2 gives us -2. After 2 seconds have passed, the velocity will change by 2. So -2 plus 2 gives us 0. Okay. So what happened here is that we went from moving, okay, and then we slowed down, and then at here, whenever your velocity is 0, we stopped. Okay. Now, if you remember, if you have a 0 velocity with any kind of acceleration, the object will speed up towards that direction. So after 3 seconds, the velocity of 0 would change by a factor of 2. So now we have 2 meters per second. So now we are speeding up. After 4 seconds, the previous velocity will change by a factor of 2, so this will now be 4 meters per second, and so we can see it came from rest, and now it is speeding up. So it was slowing down, it came to a stop, and then it sped up. Okay, so this is one way of looking at acceleration. I like to illustrate it through the use of graphs, so that you can really see what's going on with the numbers. And of course, you can always use the equation above and use the table to see exactly how everything went through. So for example, if I want to use this chart, right, we have A equals delta V over delta T. Okay, that is our equation. And we can see that this holds true. Let's see if the acceleration really was 2. All right, so we can see that our final velocity was 4. And our initial velocity was -4. So remember, it's always final velocity minus your initial velocity. So 4 minus -4, all divided by the change in time, and our elapsed time was 4 minus 0. And so we get 4 minus -4, which is 8, divided by 4, and our acceleration, lo and behold, is true. It's 2 meters per second squared. All right. Now, the last thing I want to show you is the calculus of acceleration. So let's do a quick reminder, okay, of what we determined before. We determined that dx dt, okay, the first derivative of a position versus time function is velocity. Now, the way it works out is if we take the derivative of a velocity function, so dv dt, we get acceleration. Okay, so this is the new formula for the acceleration using calculus, using our derivatives. Now, there is one other way of writing it. You'll notice here that we're taking the derivative of a velocity function, and we can also state that the velocity function is also the derivative of a position function. And so this is one way, this is formula 1. Another formula that you can say is that acceleration is equal to, see what I do here, to the second derivative. So the second derivative of position will give you our acceleration. And this is true because our first derivative gives us our velocity, and taking the velocity or taking the derivative of a velocity function gives you your acceleration. So doing this process twice gives you your acceleration. Okay, all right, let's do a couple examples. So I'm not going to work with numbers too much, but I just want to show you how we can use the calculus and the power rule to get to the acceleration. So for example, if you're given the function xt 4t to the third minus 2t plus, I don't know, 8. Okay, if I wanted to find the velocity, we can say dx dt, which is, by the way, the velocity, is equal to 3 times 4, which is 12. 3 minus 1 gives you 2, minus 1 times 2 gives you 2, 1 minus 1 just gives you 0, and any variable to the 0th power just gives you 1, so this is just 1 right there, plus, and we have no variable here, so this is just 0. Let me get rid of that little dash. So this is the equation to find, or this is the function for velocity. Okay, and if we wanted to find the acceleration, we can take the derivative of this function. So d squared x over dt squared, 2 times 12 gives us 24, t, 2 minus 1 just gives us 1, so there's a 1 there, and this is just a constant, so we're going to leave that as is. Okay, so here we started off with the position function. From there we derived the position function to give us the velocity function, and from there we derived it again to find the acceleration function. So that's one way of looking at it. And if the problem tells you, like for example, when t is equal to 1 second, you can tell me the position of the object, the velocity of the object, and the acceleration of the object. So let's try that. If t is 1 second, that means 24 times 1, the acceleration was 24 meters per second squared. If t is 1 second, then 1 squared gives us 1, 1 times 12 gives you 12, 12 minus 2 gives you 10. So the velocity was 10 meters per second. And the position, 4 times 1 is 4, minus 2 times 1, what's that? 2 plus 8, so that's 10, right? Hopefully I did that right. Yeah, x equals to 10 meters. Right? So we can see that at 1 second, this is the information that we can gather, all from that one function. All right, so I just want to show you how to do this with a different kind of notation. So we can also say x of t is equal to, let's say, I don't know, negative 7t to the fourth plus 2t squared. We'll just leave it at that. The first derivative, we can write it like so. Okay, so 4 times negative 7 gives us negative 21. T, 4 minus 1 gives us 3. Plus 2 times 2 gives us 4. T, 2 minus 1 gives us 1. So this is our velocity. If we do that again, we can write it like this. 3 times negative 21 gives us negative, oh boy, 63 t squared, plus 1 times 4 just gives us 4. Okay, so that's one way of writing it. We can also write this as v prime t. It's really up to you. Personally, I prefer this method over here, but that's just a personal taste. All right, so we covered a lot today. We covered over the definition of acceleration, what it is not. We learned about this chart. Once again, this chart is very important. Make sure you get this chart down and into your brain. We saw in chart form what acceleration does to a velocity as time moves on, okay, and what it really means. Remember, it doesn't tell us how fast an object is moving, but more so how much the object's velocity will change. And we also came across the equation for acceleration, and the equation for acceleration, just in case we missed it, is dv dt or d squared x over dt squared. All right? See you next time. Bye-bye.